Hello everyone, in today's video we're going to implement an MCP server with SSE server transport. Alright, as usual, we'll create our service as start of string.io. Feel free to choose whatever you want, auto, Radar, Java, Spring Boot version 3.4.5. We'll name it SSE MCP Server Demo, Java 21. For dependencies, we'll need only MCP Server here. And that's it. Let's download, unzip, and open it using your favorite IDE. Here I already opened it using my IntelliJ, and if you look at the build of Radar or pom.xml, we'll see the dependency Spring AI Starter MCP Server. Back to our documentation. Here we see standard MCP Server, which is Spring AI MCP Server Starter, which is outdated. So actually it should be Spring AI Starter MCP Server like we have here. But anyways, so this standard MCP server only supports the standard I/O server transport. Since we are working with the SSE server transport, then we have to choose between web MVC server transport and WebLove server transport. Here we're going to use the web MVC one. Okay, then let's copy this dependency and paste it here. So it should be the same and adding the web MVC. Okay, web MVC. And that's it, reload. Okay, for setup an MCP server, it's all about configuration properties. Here we rename it .yaml for readability. Okay, let's set up our server based on the MCP server properties. MCP server properties. So MCP server properties, and this is the config prefix Spring AI MCP server, and we will have all the attributes here. So this is the default value, right? So by default, our MCP server enabled by default. Okay, so Spring AI MCP server, Spring AI MCP server. The first one is enable, right? So it's true. Okay, let's list down all of the stuff onto our application of YAML. And SDIOs fails mean that by default we are using the SSEs. STDIO, standard IO, fails. Name. Okay, name. Default is MCP server. Okay, let's give it this application name and version. Okay. By default, keep the version default. Instructions, no. So instruction, no, we don't need to add that. Resource chain notification. Okay, resource chain notification, true. So it's tool chain notification, true as well. So keep everything default. We would like to list all of them so we know what we are going to provide. Capabilities our MCP server is going to support, right? From chain notifications. Base URLs, at the moment, this one is not stable yet. So basically keep it empty like this. And now go to the SSE's endpoint here. By default, this one is /SSEs, and this one is important since this is the endpoint for server sent event to a client. So it's a GET request, and we'll experiment it later. Now let's make it a little different value than the default one. So for example, we will change it API verse1 SSEs. The next one is also important as well, is the SSE message endpoint. SSE message endpoint. By default, it is /mcp/message. So in order for the client can connect to a server, the client need to know the SSE endpoint. And when the client creates a SSE connection to a server will return the SSE message endpoint to the client. This is important as well. And let's make it a little bit different as well. /API /ver1 MCP. Okay. Next one, type sync and async. Type sync. So this, which is also the default one. Okay, that's it for setting up an MCP server. Besides that, let's enable log for our demo. logging level, io.motor-context protocol, and trace, and aux.string framework, .ai.mcp trace as well. Alright, that's it. Our SSE MCP server is ready for serving requests. Okay, then let's run it. Okay, cool. Then let's move on and open Postman to test it. Here, I'm in Postman. And let's create a new request. Then we'll see here we can change the request, the symbol HTTP request to the MCP request. So if you don't see the MCP request, update your Postman to the latest version. Here I'm using version 11.45.6, then MCP and HTTP. And here we're going to add our SSE endpoint, which is ATA. So this is our server, right? And this is the endpoint of SSE's API verse 1 SSE's API verse 1 SSE's. Okay. Then connect. Okay, now we connected. And then we can see the timeline. So connected to the server. Then we can see the log here. So here the new request coming. It's going to create a new SSE connection, and then the client send the initialize request, and after that send a notification initialized, and after those two requests, the initialization phase is finished, and then we can start sending some operational requests like request a list of tools, request a list of resources, and request a list of templates, for example. So basically, with just one click here, the Postman MCP client is going to call many requests for you. So basically, you can see here now, you can see all the tool available, all the prompt available, and all the resources available. Since we are just have an empty MCP server, so both of them is kind of an empty. Okay, cool. Then let's disconnect it here, and then disconnected from the server. Now let's go ahead and add something to our MCP server. So back to the documentation. Here's the configuration properties that we just added to our application.yaml, right? And here's the server capabilities. So we have 4 types of capabilities: tools, resources, prompts, completions. So in our demo today, we only add tools to our MCP server. For resources, prompts, and completions, you can take a look at the documentation below here. So adding tools, adding resources, adding prompt, completions. Okay, here only focus on tools because for me it's the most useful features of MCP server so far. And we can disable this capability as well by setting these properties to false. By default, all capabilities are enabled by default, which is we can add it here. Capabilities, AI MCP server capabilities, completion prompt, resource tools, MCP server capabilities here. Okay. But at the moment, to be honest, this one is not in the MCP server properties. But if you take a look at the master branch of the String AI projects, we'll see capabilities here in this class. Anyway, in this version, RC1, right? Yeah, RC1. Basically, these are not really being applied in the MCP server properties, but it should be available in the new version, and it should be appeared in the MCP server properties as well. Okay, just add it here. So in futures, maybe we upgrade to a new version, then we don't have to find them and configure them. Okay, back to our tools. So for register a tool to an MCP server, it's pretty easy that we just need to provide a toolback provider, and it will automatically configured into our MCP server. So for example, let's try to create our tool. So we have a math tools, for example, sum two numbers and multiply two numbers. So we have 2 functions here, and if we would like to make a function to a tool, we can define the annotation, tool on it. And the most important thing is about the description. So the LLM will using the description to determine when it needs to call our methods. And in the method, we can do whatever we want. Like we can interact with the database, we can call API of other services to get information, and we can do anything with our method. And by adding a tool annotation, then we can use it to create a tool callback provider. Okay, we have a math tool here. Here we have to create public tool callback provider. Just return a method tool callback provider dot builder dot tool objects, and new. Here's we create a new instance of our math tool class here, and every method in this class annotated by our tools will be registered. Okay, build. That's it. Then bin. Okay, then let's try to restart. Okay, and we take a look at the log. So now we see registered tool 2, and the notification is true. Notifications here, tool chain notification, true. Okay, then here connect again. Then you see timeline connected to server, and now we have 2 tools available for us. For example, we pick this one, and then for the first number 5, and then we send this one. Then we send a request, right? So a new request is sent to server, which is we would like to call a tool, right? So the method is tools called, and the name of the method is multiplied numbers. With the first number is 4 and the second number is 5, and here is the result from the server, which is 20. So what about if we have another class that also contain a tools, and we would like to register those tools? For example, we're going to have a daytime tools which contain 2 more tools, and we would like to add them to our MCP server as well. So basically just create another tool callback provider. Here another bin of tool callback provider. So let's say now we want to create a daytime tool. Okay, new instance of daytime tools and daytime tool. That's it. Let's restart. Okay, now we have 4 tools registered. Then connect again, connected to server. Then we have set alarm, right? Get current time, which is don't have any params, and let's run it. Okay, so get current daytime, and then it's going to return a response from our method. Alright, our SSE MCP server is now up and running. Next, I'll go a little bit deeper about the protocol. If you're not interested in it, thank you for your time and see you in the next video. Alright, so as you know, we have been using Postman MCP client to test our MCP server. So what really happened behind this MCP request? So as we look at the log, we know that this MCP request is a collection of requests, represents a protocol lifecycle of the MCP, of the model context protocols. So we're going to the base protocol lifecycle. So here we see this is the lifecycle of the client server connections. First of all, in the initialization phase, we have to initialize requests, right? As you can see here, we're going to initialize the request, and after that, we send a notification initialize. Send notification initialize. After these 2 requests, the initialization phase is done, and then the client can send another request to the server, like a get list of tools, get list of resources, or calling a tools or something, calling a tool. Okay, then let's break our MCP request into pieces and code each piece manually. First of all, we need to start with getting an SSE connection. Okay, Let's clear the block first, and then we're going to send a normal HTTPs. So first of all, we need a simple GET request to our SSE endpoint, right? Here, SSE endpoint, API for one SSE, API one for SSEs. So this one is going to create an SSE connection to our server. Then send. Here you see, we are going to connect to our server. So you see, the time is increased because our connection is keep alive until we close it. So, and the server will return an SSE message endpoint, which is here. So because we declared API version 1 MCP, so that's why our server returned us on the SSE connection, right? So you see all the thing happen here is in one SSE connection. And then the client can use this one to send requests to a server. So this channel is only for sending for server sent to the client. And if client want to connect to server, they have to code this one. So localhost, right? MCP server at localhost 8080, and this one is the post one. So with a section ID, you can see here the section IDs should be the same, right? Should be the same. Okay, and first of all, the initialization phase, the client need to send the initialize request. So here's, for example, this is the initialize request. So method initialized, bodies raw, and then going to send an initialize request. You see the method initialized, the protocol version. So for example, the version negotiation also happened here. For example, we have the version, the newest version is 2020 here. And then if you update this version here, then let's try to send. Okay, 200. Okay, and without any response, right? If we take a look at here, we'll see the a server response on the SSE connection. It's not respond directly on our post request here, but it's respond on the SSE connection. And it said that the current protocol version supported by Spring Boot MCP Server is the old one, right? 2024, the old one, 2024 for November 5th. So there's here we take a look. So client initialize the request. So we send a request from client, right? Here is the client send a request, and then the protocol version is unsupported, and that's why the server will suggest using this one instead. So you see the version negotiation happen here. Okay, so the next request is the initialize notification. This one, initialize notification. Wait a bit. Here I'm going to copy this one, create another request. It's a post, and the body should be this one. So the method is notifications initialize, send 200. Okay. Okay, since it's a notification, so that's why we don't have any response back in the SSE connection. But now the connection is ready for our operation request. So with two requests, here the initialize request and the initialize notification. Now we went through the initialization phase, and our SSE connection is ready for the normal protocol operations. Okay, let's try to list all the, let's copy this one. Okay, and body post. Now we would like to list all of the tools provided by the server. Okay, the method tools list, mean list all of the tools, and we send to it OK. And if we take a look at the SSE connection here, we'll see new message is sent from our server to client, which is all of the tool, you see. So we have one tool, get current datetime, sum number, multiply numbers, and set alarm. Okay, so, and now, for example, let's code false here and body seasoned. Let calling a tool, the multiply number tools, and the first one, the first number is 2 and the second number is 5, and send. Okay, and here you see the result is 10 and it's returned from the SSE connections. Alright, well, that's pretty much it for this video. I hope you can get a chance to try it out soon. If you enjoyed the video, click the like button and subscribe. That's help you get more similar videos in your feed and helps me reach more developers like you. Thanks so much for hanging out with me today. See you next time. Happy coding!